Hello, I'm Ettore, a Rocketeer and a student of a school previously founded by Elon Musk. And today I interview the AGH Space Systems team from the University of Krakow in Poland. So could you please introduce yourself and your team?
So we are members of AGH Space Systems. It is a student construction team that is operating at AGH University of Science and Technology since 2014. We work on developing sounding rockets, stratospheric balloon gondolas, and a planetary rover named Kalman. And currently we have around 70 members in our team, so quite a lot, and they come from various fields, from mechanics through electronics, software, and even social informatics. And maybe I'll start with myself. My name is Nina. I'm a member of the management board in AGH Space Systems and a marketing team, and I take care of operating marketing activities of our association, and I also take care of fundraising. So I coordinate preparing grant applications and stuff like this.
So my name is Radek. I'm a graduate student of mechatronics engineering, and I'm also a hybrid rocket team lead. Duties are to actually try to coordinate the whole team to make everything happen for both the competitions and for the ongoing projects. And also I'm part of the mechanics team, so I work on the rocket structure and the general mechanical part of all subsystems.
Well, I figured I would go last, since I am lowest in rank here, since I'm just a regular member, no leader of anything. My name is Wojtek, and I am a member of the rocket electronics team. AGH Space Systems started out initially in 2014 building CANSATs. Then we expanded our activities to experimental rockets, and then also rovers, and the CANSATs activity was then kind of left behind for those new projects. And ever since the beginning of our activity as experimental rocket builders, we have been at work developing mainly hybrid-powered rockets. But we also had a liquid-powered rocket as a sort of maybe secondary project, which we also demonstrated once at Spaceport America in the past. And by the looks of it, this is the project that is now going to become the main project of our organization, since we want to try and develop a bit more in the direction of liquid powered rockets, of liquid fuel powered rockets, to sort of expand our ability and our knowledge of different types of drives. Perhaps more about me. So as I said, I'm a member of the rocket electronics team, so I'm mainly concerned with developing hardware and software for our electronics system in the rocket. So this involves, as I said, hardware design, electronics assembly, programming, testing, integration with the rocket, as well as, using and actually servicing the rocket electronics during different types of competitions.
Hi, my name is Bażela. I'm a graduate student of biomedical engineering, and I am a rocket and balloon experiments team leader. So my main role in the team is designing and managing the experiments that fly in rockets and stratospheric balloons. As for now, mostly biological experiments. I also sometimes help with the rocket structure, particularly with manufacturing composite components.
How did you start your team?
Our team was started back in 2014, so none of us was at the university back then, but we heard a little bit about this. Our team was started by 7 members who decided to build a CANSAT and take it to a competition in the United States. They actually succeeded, and a bit unexpectedly they won at the competition in the United States, which really boosted the growth of our team and of the whole association. And right now we have not 7 members but 70, so quite a lot. About like how many do we dedicate to different different areas of development, like marketing or electronics or software. It's hard to say. I think we try to be like devoted and have members that work hard on all of these areas. From my part, I can say that in marketing, for many years we didn't have separate section of marketing. There were like 2 or 3 people that were taking care of social media and contact with sponsors, but since this year we have team of marketing that has 10 members, and we are working really hard to promote our activities.
Yeah, and I think it's also really hard to actually put a number of hours that were spent on each subsystems and department, because it's such an interdisciplinary task to actually build such team and to build those projects that somewhere along the way you kind of find yourself doing basically everything. So even if you're a part of one team, that doesn't mean that the only focus is on one particular subject, but you can also find yourself in some new areas.
Payload team actually also emerged only recently, because in the beginning we didn't have like a group of people dedicated specifically for experiments, and we didn't even recruit for that. And for example, from my experience, I was doing recruitment tasks along with the mechanical engineers. So it was quite a stressful experience for someone that just wanted to do biological experiments.
Generally, it is, as Radek said previously, it's hard to quantify really how much percentage is devoted to each of the departments, since everybody is putting in a great effort. And I'd say it also depends heavily on the stage at which the project is at any given moment. So let's say at the beginning, there might be some more work to be done by, say, the mechanics team for like designing different parts of the rocket. And then perhaps towards the end of the development cycle, when we're actually building the rocket, some of these designs are actually manufactured by external contractors. And for example, the composite team, which actually manufactures the parts themselves, then goes to work on actually manufacturing these components, and then they are putting the most effort and the most work in, and the largest number of hours, because that's just kind of the stage at which the project is. So it really depends on what is to be done at any given moment. We do our best to work on all components simultaneously, so that everybody has something to do. But sometimes there are blockers. Like one team might be waiting for another team to finish working on something that is a dependency of their system component. So when we encounter blockers like that, one team can have a little bit of a time off while the other is working. And then while the first team is done, then they have the time off and the other team gets to work. So it really depends, and it's quite flexible, but we always try to put maximum attention to all of the departments and their needs, and the impediments that there might be encountering, and try to eliminate them and make work as easy and as enjoyable for everyone. So that's my 2 cents on the issue of like kind of resource management. If you don't mind me asking, Ettore, what is, of all these things that we see on the screen right now, of all these departments, what is like your favorite department of rocketry, or perhaps the one that you dedicate most time to in your free time?
So I think it will be structure and propulsion. I think it's my favorite because I am not good with electronics, with software. Then I find the recovery slightly boring. Payload, I never know what to put on top of my rockets, so I'm not good at it. Scientific experiments, I normally do them on Earth. I don't need to do them on the atmosphere, so I kind of don't care. So structure and propulsion.
You're quite good with public relations, but
yeah, that's what I was going to say. Yeah, actually, I think you're downplaying yourself here, because I think your public relations skills are quite good. And when it comes to programming and electronics, I'd say it's just a matter of time. Of course, it's not for everybody, I understand, but I myself being an electronic engineer and an embedded software development, I'd say I only got into it in, let's say, the latter part of my life. So I'd say perhaps there is still a chance for you to be interested in that. But of course, structure and propulsion, I'd say even myself being an electronic engineer is far more exciting, just because of, I mean, it's pretty amazing what these propulsion systems are capable of. So I definitely understand your point.
So how is your university in Poland, and do you study in English or can you only study in Polish?
At our university, there are majors that you can take 100% in English, but most of the majors that we have are actually in Polish for the most part. Now, English is still necessary because, especially towards the end of the university program, there are a lot of subjects which are, let's say, quite specialized, and in those fields, usually, the cutting edge of technology is developed abroad. So let's say in the US or generally in the Western countries, where let's say the standard mode of operation is publishing in English. So even if the subject is technically in Polish, we do use a lot of English language literature. So it's still a necessary skill, and we all learn English at university as well. And I'd say the great thing about studying in Poland is that generally studying at university is free at public universities. There are private universities where you can pay to attend, which offers certain advantages. But in general, it is free of cost to study in Poland, and the dorms are quite affordable as well. When it comes to space attractions, I am personally not aware of many space attractions in Krakow. Perhaps other members of this discussion can add a bit more to this point. Now, when it comes to student life, however, I'd say Krakow is pretty nice. Perhaps not the best out there, but it's got its strong points. Our university in particular has a pretty unique campus, which offers clubs, pubs, food trucks, pitches for playing sports, and general areas for hanging out. Concerts are often organized in the area, so I'd say there's definitely something to do at any given time. And when it comes to Erasmus experience, I would definitely like to go someday, but I haven't had the chance yet.
Yeah, coming back to this topic of student life in Krakow, I'd say that it's quite nice in this respect in Krakow, because we have like 23 universities in Krakow and about 200,000 of students. So there's a lot of students. And at AGH, for example, once a year we have this big celebration, big party for students that is called Juvenalia, and it's really wild. For a few days we don't have any classes, but we can just party. There's a big parade, there are concerts and stuff like this. And also about this space attractions, I don't know any in Krakow. But coming back to the topic of space and university, we also don't have yet any space faculty at AGH, but it
is in the making.
Yeah, it is in the making, because there is this project EuRoC. It is a cooperation between AGH and some other European universities, and the purpose of the project is to create faculty in a space industry that will work like that you can study on different universities, half a year at each of the universities, because none of these universities have enough professors and enough resources to create the whole faculty, but each university will provide just one semester of studies. So we'll see when it happens, but I know that it is already in progress. And also this EuRoC project is good for students that want to develop in the area of space industry, because they support going to different space conferences and making space projects. So that's great.
Yeah, I think when it comes to studying some space-related faculties, it's definitely an issue. It's becoming less and less of an issue because there are new faculties opening as we speak. But still in Poland, I think that maybe 2 universities, 3 universities offer some kind of a program that's space related, and
Warsaw, right?
Yeah, in Warsaw, in Gdańsk, and also in Rzeszów. So yeah, those are like 3 main cities and main universities. And I think that's the most tricky part about trying to do something space related, because you just have to learn a lot on your own. You have to source this knowledge, verify it. So there's not a lot of people that you can actually talk about some intricacies of space engineering. So yeah, that's I think that's the biggest problem when you're trying to develop a project or something. But like I said, it's I think progressing with each and every year. So yeah, hopefully we will see a lot of space universities in Poland in the future.
I think I might add something to the attractions point. I think the closest thing to the space attraction that we have near Krakow is the Analog Astronaut Training Center. I know they're sometimes organizing like these trips to speak about space projects and stuff, but it's not in Krakow, it's like near.
What are the job opportunities after your university?
To be fair, I have not been offered many aerospace-related jobs, especially here in Krakow. Honeywell did contact me on LinkedIn, like recruiters from Honeywell in Czechia, but of course that's quite far away. So I am aware of one company in Krakow or near Krakow that is concerned with aerospace, but its office, as I said, isn't exactly in Krakow. It's somewhat remote, and I am not really that interested in its particular projects. So I am currently working in the automotive industry as an embedded software developer, writing code in C. And well, the reason for that is with electronics, many of the principles used in aerospace, which I learned at AGH Space Systems, carry over very well to industrial and automotive applications. Some of our alumni, however, did create startups, and one such example would be Progressia Space, which develops propulsion systems for small satellites. And indeed, some members of our organizations ended up working for them or for other space-related startups and companies. So there are definitely possibilities out there.
Because I only wanted to mention Progressia also, because I think this is like the most related thing to space industry that is being done by people who were in space systems before. Apart from that, we have also some people who created startups in the area of robotics, but this is not really space industry, but more just practical robotics, not being sent to space.
Past members of the AGH Space Systems that are currently working in the space industry, either in the military technical institute, or for example, I myself work. I've actually started quite recently working for the Polish Institute of Aviation. So it is possible, and definitely being a member of the AGH Space Systems helped me a lot to gain a lot of skills, a lot of experience. And since, like we said earlier, there are not a lot of opportunities in Poland to actually study something space related. The student groups that work on such projects are the main resource for future employees for those companies, because they're the people that actually want to learn this stuff. They want to develop in those areas. So yeah,
and I mean, I think also networking is a big part of our activity, since it also helps quite a bit with getting to know people from the industry, and also getting recognized by them. So putting yourself out there, showing that you're putting in the work, and also going to events where there will be people looking for people just like us, really, interested with space, working for popularizing the space industry in Poland. So I say we are looking for them, but they're also looking for us. And by participating in different space-related events as members of AGH Space Systems, we're putting ourselves out there, and definitely getting more opportunities to be recognized and sort of headhunted for these companies.
What are your team's goals?
Now we're mainly focusing on developing paraffin-based fuels for our hybrid rockets. And also, as mentioned previously, we really want to develop and to to sort of summarize the project of our liquid rocket engine and liquid rocket in general. That's been in the making for quite some time, and we want to expand this knowledge and to actually develop. I think it would be the first liquid propelled rocket in Poland. If maybe if you guys know, correct me, but yeah, I think so.
I think that there was another rocket for fuel, but it was never launched. It was constructed, but it was never launched. So it will be hopefully the first one to fly.
Yeah, that's exactly what I meant. Yeah, the first student created and hopefully launched liquid rocket.
So I can talk a bit about the Payload team goals. So the short-term goals include launching our Shrimp 2.0 rocket payload in Poland. We originally developed it for Spaceport America Cup, but couldn't launch it in USA. In brief, the project is about developing a safe way to transport Neocardinia davidi shrimps in a rocket. And shrimps could one day be a part of a aquaponics system on other planets. Recently, I also expanded this project and tested the shrimps in an actual aquaponics system. I did it in LunAres Research Station in Poland, an analog moon station, and I plan to continue that project and also involve more team members in it. And as for the long term, we are now starting working on a new rocket payload, a life-sustaining unit for insects and small animals, and we want the mealworm to be the first one to test it. We are also doing experiments in stratospheric balloons. So right now we are in the middle of the series of missions that we started almost 2 years ago with different human cells on board the balloon to test the space radiation influence on them.
We also have some other side projects because this year we intend to go to IA SciTech conference in United States, and we got already 3 or 4 abstracts accepted for the conference. And one of the projects that is quite new is will be to test the influence of isolation and lack of sunlight on the parameters of sleep, because there is in Poland there is this analog space station LunAres where you can go for 2 weeks and take part in the simulation of space mission, and we intend to make a study on how this participation in the mission influences parameters of sleep, as we think this can be interesting and bring new light to how to improve sleep of astronauts during real space missions.
Something from the electronics team side as well. We're constantly working on refining our firmware, our embedded software for the rocket. So right now on our roadmap is the refinement of algorithms for our recovery system. We are also polishing our communication system to ensure that it is as reliable and as practical to use and modify as possible. And we are also at work implementing some testing frameworks, actually inspired by our commercial experience in huge corporations. So we kind of recently, some of the members of our teams had a chance to learn about state-of-the-art testing and verification practices used by corporations worldwide, and we figured that it would be very it would be worth implementing in our organization, both to, of course, bulletproof our embedded firmware, as well as teach the up-and-coming electronic engineers about these practices so that they are ready to implement them and ready to use them when they enter the commercial electronics industry themselves.
How do you recruit members, and how can members join your team?
We have recruitment every year, usually in October, and the way to recruit to our team is to fill in the form, the form and answer the questions about the skills, the reason why someone wants to join our team and stuff like this. And after participants fill the recruitment form, we invite them for just short conversation to verify what skills they possess and why they want to join us and things like this. And usually we have quite a lot of people that are willing to join our team, as we are quite well known at our university and in Krakow. Last year, I think we had like 130 people that filled the recruitment form and wanted to join us.
The people that we are looking for doesn't necessarily have to be some space engineers, and then they don't have to possess the knowledge about space engineering of any sort. We're looking for people that are eager to learn and that really want to put in the effort. Like I said, it's such an interdisciplinary task that you, basically, if you know anything about electronics or mechanics or any different part, biology and then so on and so forth, so you can find a sort of niche for yourself. You can find something that you can really work on and focus, and that maybe you implement it in the overall system, so in the project.
Of course, most of our members are from AGH University, but the candidates can also be from different universities in Krakow. For example, in the Payload team, we have one person from Jagiellonian University. She's a neurobiologist, and in my opinion, it's good to be open for people with different backgrounds and not be limited to only engineers. It's really beneficial in such interdisciplinary projects like building a rocket.
What can members learn in your team?
I wanted to say that it depends on the department or the subsection that they join, but that really isn't the case. Of course, this is probably the area that they will focus on, but truly in such an interdisciplinary team as AGH Space Systems, regardless of what you're doing, you'll always pick up something from the other sections as well. Because, as Radek said, these activities are so interlinked between each other that you're always bound to learn something from the other sections as well. And there is a lot to learn. So from the electronics perspective, it's of course PCB design, so electronics design at the hardware level. There is systems design for how to design the communication of systems and the different responsibilities of different electronic units. There's software development for the embedded applications that we develop, and all the algorithms, recovery systems, electromechanical components such as valves, the feed system. There is radio communication. So a lot of different disciplines, even within electronics themselves. There is also PCB assembly, since we assemble our own electronic units. So, you've got soldering. There is also measurement methods using oscilloscope, multimeters, and similar. And of course, different, testing methods. So methods of how to test that what you built actually works. And of course, this involves different types of tests. So, for example, for avionics testing, you will have, for example, drop tests of the electronic units, which are always fun. There is data processing, so that you actually can, gain insights from the tests and from the data that is collected during the tests. So that, of course, involves data visualization, analysis, all sorts of things. So there is definitely a lot to learn. I could say more about what other subsections or other departments offer, but I think there are better people to answer that question on the call. Of course, Radek and Basia. So perhaps I'll hand it over to them.
Okay, so in the Payload team is actually a mix of skills, because it's its own miniature interdisciplinary team. Because we need biologists, we need someone to deal with the electronic sensors, we need someone to deal with the mechanical design. So basically, I agree with Wojtek that you can learn whatever the other team members can do, because they are usually eager to share the knowledge that they possess. And from my perspective, I joined to do biological experiments, but I ended up also helping with the structure and definitely learned a lot along the way.
Yeah, I'd say the Payload team is probably one of the best teams to join if you want to gather, interdisciplinary insights from different departments, because it really is a very interdisciplinary effort, which involves, as Pasha said, electronics, mechanics, biology, everything. You basically have to gather it all up and sort of manage each side and really know what others are doing and understand the principles of all these other departments, because it's really tightly knit together in this subsystem of the rocket.
Yeah, and what you end up with is basically people from electronics team that are grinding something, and people from mechanics team that are, for example, soldering some connections when the electronics team is busy with some more important stuff. So yeah, just to summarize, the effort is like the joint effort of all areas, I think. Yeah. So it's not like you're basically sentenced to learn only one thing and one thing only. Basically, designing a lot of parts, making some analysis. Speaking a little bit on behalf of the propulsion team, they also concern themselves with a lot of CFD, with some chemistry and so on, some thermodynamics. So yeah, it's there's a lot to learn, and a lot of effort must be put into to actually gain all of this knowledge. But yeah, it's possible. So.
Yeah, just to add, I think that no matter in which area you work in our team, definitely the skills that you get are organizational skills and managing your time on a tight schedule and just dealing with crisis situations, because they happen on the way. Just to put an example, Radek this year had this crisis situation when we had a problem with transportation of our rocket to Spaceport America Cup, and he just spent all day all alone on the airport trying to just get the things done and go somehow to the United States with all the parts that were needed to be transported.
How do you manage your team?
Our association has 3 sections: rocket section, rover section, and marketing section. So members of the rover section are not today here with us, because I know that you will be doing another interview with them in a short time. So as I said, there are 70 people, around 70 people in our association. So we don't really have many meetings all together, because it doesn't make sense. We only have them like 2 times a year, an official meeting. And apart from that, every section has their own meeting about once a week, where they discuss all the important information and the plans for the future and what's going on right now. And for example, I think we don't really use any specific methodology to manage our actions. We just try to be flexible and do whatever it takes to complete a project. In marketing, we use Trello, for example, to plan everything and just realize what's going on. But apart from that, there is just marketing leader that has to control if all the things that are planned are being done. And we also have a management board. So these are 3 people that take care of the operation of the whole association, and they watch if all the deadlines of grant application and stuff like this are being met, and if we have fundings for our actions, and if we spend like money in a proper manner.
How's the experimental rocketry community in your country?
It's definitely growing a lot, especially in recent years. I think there are more and more teams that are focusing on both the rocketry and in general in some space-related research. Some students' organizations. There are more and more companies that are actually involved with such stuff. More and more companies are actually taking the challenge to enter the world of space engineering, which is quite daunting at the beginning, but over the span of the time, the more and more is appearing. And I think that's a general trend in Europe, actually, that more and more people get involved with space. They want to know how where we are in the universe. They want to explore. They want to achieve some really great things. And a lot of people, especially young people, are getting more involved. And we also communicate we try to stay in touch with other teams in Poland. It's such a tight community that we meet a lot on different occasions, on some conferences, on some competitions. So you see the familiar faces all the time, basically.
We even have a group on Messenger with members of all 4 Polish teams developing experimental rockets, where we can communicate about, for example, competitions or different formalities associated with participating in them, or just sharing information or talking about space-related things, which is great. Frankly, to be able to have access to such an amazing, thriving community of young aerospace engineers.
And I think that the Polish Rocketry Association is actually doing a lot for the rocketry community, as it's organizing the experimental rocket launches every year or even twice a year. Also some rocketry workshops and other events. And I also think it's worth mentioning that the space community outside of rocketry is also growing in Poland. For example, we have the Polish Astrobiological Society, which I recently joined, that is organizing conferences about life sciences in space. We also have analog habitats mentioned earlier, such as LunAres and Analog Astronaut Training Center. They are also gaining more popularity and doing various space-related research.
Yeah, and just to add, because Basia mentioned this conferences on astrobiology, actually we also have at AGH University Space Resources Conference that is organized every year, and there are always some talks and lectures about space-related topics. So I think it's really developing field in Poland, and I hope we'll see it grow for the next years.
And also, I think just last year, the Polish Space Agency jumped on the Artemis ship. I think when it comes, because we weren't so much involved in the cooperation in the program. And I think last year they signed the contract that they want to be a part of that, and they want to help develop the different parts and different parts of missions.
So how do you promote your team?
We concentrate most on social media. Right now, our biggest fan page is on Facebook, but we also have Instagram, Twitter, and LinkedIn. So there's a lot of material about that out there in the internet that you can look for. We try to publish posts on Facebook about 3 times a week. About 2 or 3 times a week. And we also make a lot of Insta stories to show what's going on in our laboratory and to show projects that we're working on. And apart from social media, we try to take part in various conferences and just various events to show that we're here and to just attract people and promote our activities. We also make workshops for kids about different topics in space engineering. So I think these are our main methods of communication.
What are your experiences at EuRoC?
Is that all you got? Yeah. I only got one question. So is that all you got? You go big or stronger. You push harder. Is that all you got? You climb higher, faster. So is that all you got? You put your best and the rest in, no resting. Is that all you got? So you a victor, I only got one question. So is that all you got? Yeah, look at you now. So is that all you got? Take a look at you now. So is that all you got? Look at you now. Is that all you got? Yeah, I only got one question. So is that all you got? Yeah, look at you now. So is that all you got? Take a look at you now. So is that all you got? Look at you now. Is that all you got? Yeah, I only got one question. So is that all you got? Make it to your bottom, you just gotta keep on digging. Whether you doing it for the family, if you doing it for some millions. Cause it don't matter either way, that's any season, any day. Baby, I grew up in winning ways, so I'm not about to play. I paid all my dues and learned the game, yeah, the harder way. To conquer enemies, I hit the mark and take their heart away. I never been a loser, I'm a king like Martin Luther. Even when I'm not open, I drop the shot cause I'm a shooter. I only got one question.
Tak jakby nie poszedł zapalnik, a otworzył się main. Moim zdaniem to tak wyglądało. No.
So is that all you got? You go big or stronger, you push harder. Is that all you got? You climb higher, faster. So is that all you got? You put your best in the rest in, no resting. Is that all you got? So you a victor, I only got one question. So is that all you got? Yeah, look at you now. So is that all you got? Take a look at you now. So is that all you got? Look at you now. Is that all you got? Yeah, I only got one question. So is that all you got? 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 Is that all you got?
We participated in last year's EuRoC. Unfortunately, due to some issues with one of the subsystems, we weren't able to actually launch. But the overall organizational part of the competition is really good. It's because I think we had a little bit more experience with the Spaceport America, so we were kind of able to compare those two events. But the European competition is really great. There's a lot of great teams there. It's a little bit smaller than the Spaceport, I think, because only 20 or 20-ish teams participated last year. Yeah, but still, it was a really fun experience. A lot of lessons learned, and we really were able to meet a lot of great people and talk to teams from all over Europe. So yeah.
Yeah, I think it was most of all the great learning opportunity, because for a lot of us, that was actually the first time they took part in such a competition and the first time they were trying to launch a rocket. So definitely we learned a lot about, doing such a project in this.
When it comes to this year's EuRoC, unfortunately, since we're basically leading two separate major projects at the same time, with the project being the rover and the sounding rocket, the budget for those activities is the main concern, I think, and both teams participated in the Spaceport America and the University Rover Challenge in the United States. So yeah, so this year we decided to focus more on the research side of our activities and hopefully participate in the next year's EuRoC.
What are your experiences at Spaceport America Cup?
Basically, for all of us, it was the first time this year to be there. Some members of our team have been there before, and I think that last two times were phenomenal from what I've heard. People really enjoyed it. It's a lot bigger event, over 100 teams, so the launches are like non-stop. You basically hear the rockets launching every 10 or 15 minutes. So that's really it's something that is worth experiencing and worth seeing. And I think we're looking forward to the next year's competition. This year we had there were some issues with the experimental sounding rocket acceleration organizational part, I think, of the competition. But I think we're still really looking forward to the next year, and hopefully we'll be able to go there with the liquid propelled rocket. And we'll see.
Yeah, I also wanted to stress that Spaceport America Cup is like the biggest event of the year for the rocket team, and it takes place almost at the same time as University Rover Challenge, which is the biggest international competition of space rovers. So these are two very big events at the same time, and it's always just a giant amount of effort, not only to prepare both constructions for the competition, but also to get the funding from university and from sponsors to be able to send so many people to United States for the competitions. And we always with the marketing team, we always try to promote our participation in these competitions as much as we can, and we send mails to our sponsors and to media and to university to show how the competitions are going. There's always a lot of information about that on our social media, and we also, from recent years, we also have quite a lot of interviews with Polish press about Spaceport, as we I think last year we were actually first on Spaceport America Cup in our category, but it was in virtual because due to the COVID we were unable to attend on place, and 2 or 3 years ago we had second place. So this is really for us a big goal to go there next year and be able to launch and maybe win this time.
And the third place this year, so the podium still is ours. So
I'd like to mention one thing that isn't great about Spaceport America, and that is definitely the logistics of getting there from Poland. So transporting the rocket and then transporting all the people is a huge effort, and it takes a lot of energy, a lot of time, and a lot of money just to get to the competition. And frankly, from our perspective, I don't know if you will agree, but I'd say the logistics side of it was probably almost as much of a challenge as the participation itself, with all the issues that we have had along the way. So I'd say it is definitely worth considering how we can support the European side of things, so that these European teams, which might not have the funding necessary to fly all the way to the United States with the rocket, how we can make it easier to launch here in Europe. And I'm actually kind of alluding to the OpenLaunchInitiative, which I think is something that you are definitely doing great work on. So we would definitely be interested in making it easier to launch here, so that it can be made easier both for us and for other teams to simply get more opportunities to launch and make it more convenient, and thus conduct more tests, conduct more missions, and generally make it more popular here. Could you perhaps tell us a bit more about the OpenLaunchInitiative?
So yes, the OpenLaunchInitiative is basically the idea of having a spaceport. From what I know, I'm not 100% sure if it's like this, but a spaceport, you pay a certain price to rent it for 2 weeks, for example, so that everyone can assemble their rockets. So the idea is, if you have one team that team has to pay $100,000 as just an example. If you have 10 teams, you always pay $100,000, but you divide it per every team. So each team has to pay only $10,000 to have a spaceport for 2 weeks that you can go as high as 100 kilometers, slightly more than 100 kilometers, I think.
Sounds exciting. So, I mean, if that were possible to organize, I think that would be a very interesting initiative to be a part of.
It opens up a lot of opportunities, I think. Yeah, definitely.
Yeah, because in Poland, we are able to launch rockets that fly higher than 3 kilometers about 2 times a year. But it's like I'm not sure, but I think these are 2 or 3 days for the you have to get in this. How do you say this? Well, you have to launch during these 3 days when the event takes place, and if you fail to do this, there's another chance in half a year. So there are also not a lot of opportunities to launch rockets in Poland.
And in general, it's an issue in Poland because not only if you're a student organization, but even companies or government organizations have troubles with that. They're trying to open the space more and more. I think the apogee limit is already been taken out, but the sizes of the launch sites are quite demanding because the landing dispersion is an issue, and Poland is relatively small and quite densely populated, so there's not a lot of open spaces and some fields where we can just launch the rocket freely, because up to 3 kilometers it's not an issue. Up to even, I think, this year's experimental rocket launches will be able to accommodate, I think, 23 kilometers. But if you're planning to go higher and higher, it's becoming more and more of an issue. And there are some military sites that you may be able to launch there, but then since it's military owned, you have to comply with additional rules, and it's really problematic. So that the idea of being able to actually rent a spaceport for 2 weeks, for example, it's really great. Yeah.
How do you build your rockets, and how much do they cost?
Kind of an ongoing project, but because it's been developed and it's kind of evolving for quite some time. We're basically mostly specializing in hybrid propulsion. Like we said, we're trying to go a bit further into the liquid side of the engines, but the expertise, I think, is with hybrids. I think the main approach is to kind of iterate to the biggest problem, and the most important thing, I think, is to be able to specify the issues, the specific problems that we've had, where those issues come from. Is it some sort of the engineering problem or some communication issues between the teams? For example, when they're not really able to tell each other, I don't know, how much space we need for a component X, Y, or Z in the rocket. So those things we need to learn. And this also shows that it's not only an engineering project, it's also kind of a social project, I'd say. It's you really have to find yourself in a team and find a way to cooperate with a lot of different people that have different ideas that you may not agree with. So that's also kind of tricky, because sometimes people will say that your idea is not the one that we should go with, and you have to be able to actually take it into account and work around it. So. Yeah, and this is kind of an iterative process. We base our knowledge on previous projects, and we try to avoid the mistakes we've made previously.
Yeah, maybe I'll just add that our rocket named 3TTK is the 7th rocket built by our association. So we already have some experience, and we can base upon it to improve the structure and all subsystems. About the cost, it's a bit hard to say, because there are some subsystems that we use from the old rocket and insert them into a new structure. But I'd say, I think it's around 60,000 zloty. So roughly estimating between 10 and 15,000 euros. I don't know if I'm right, but I think that would be around this. Unless, I don't know, Radek, if you have some other estimation.
It's kind of a difficult question, because do we incorporate in that overall cost the development process, because that also plays a major part.
I was thinking more about the components, because everyone
components
knows
itself,
that students work for free.
No, but also the development, the testing, and so on. It takes a lot of time, but also a lot of money in the process. So it's kind of hard to estimate. But if you want to actually take the 3D models and the drawings and build the rocket as it is right now, I think that maybe a little bit more than 60,000.
Okay.
I think we're closer to, especially with the new structure system that we are using for this year's rocket. I think we're really a little bit more closer to the 80. I would say even 90.
Okay, so 15 to 20,000 of euros. I think that's it. And I have to stress that we get a huge support from our university on that. We are currently supported by 5 different faculties. Though our association officially operates on the faculty of mechanics and robotics. Well, there are many other faculties that support us financially, and we also have support from Ministry of Education, and we have sponsors. We have many sponsors that support us in different ways. I think the biggest ones for the rocket team are Aileron. This is company that works in a fintech industry. And they supported us financially, thanks to which we were able to go to Spaceport America Cup and to build our rocket. And the second biggest sponsor is Dunrob, that produces different parts of our rocket. But we also have sponsors who provide us with, for example, software or some smaller components. I know that there were also some sponsors that gave us shrimps for our payload, and that produced specific parts of the box for the payload. And we also have a special sponsor that gives us coffee, thanks to which we have energy to work on our project. So we have really a huge support. And I think it's also thanks to the fact that, space industry is just something interesting. So a lot of companies wants to be involved in it and support our team, even though they don't operate themselves in space industry, but in different areas.
Yeah, and because the overall cost of those projects is so huge, especially when you consider the development process. This is why it's so crucial to have this huge outreach and to be able to show that we're here, we're trying to do something interesting, and to be able to show to other people. And that's why we're really grateful both to the sponsors and the university and Nina and the whole marketing team for actually promoting us and making all of this happen, because that's basically what it is.
I have to say that it's a lot of work, but it's really rewarding seeing then that you're able to go to the competition and do really cool stuff.
How much do you build your own rocket, and how much do you outsource to sponsors?
Our rocket team is as was previously mentioned, a very interdisciplinary organization. So that means that we have people who are specialized in different parts of the industry. And what that allows us to do is to very finely control pretty much all parts of the rocket's development. So what I mean by that is we develop our project from the most basic materials and components possible through individual module design and manufacturing, all the way up to the complete tested flight-ready rocket. We've got people who work on high abstraction levels, like on app development or integration, but we also have people who are specialized in, developing the individual units or even developing materials for building, for example, airframes. So we really control very finely, pretty much all the stages of building the rocket. And what that allows us to do is, of course, it provides a unique opportunity for the students to see and learn and participate in parts of the process that range beyond the scope of their specialization, but also it lets us to adjust the rocket to our needs and make it as personalized and as application specific as we like it to be. This also provides us with unique opportunities to really, analyze each part of the rocket's development cycle and really learn as much as possible from it. To give an example, if we just bought off-the-shelf electronic components, of course we would be able to program them and put them in the or maybe not electronic components, but if we bought off-the-shelf electronic units, we would be able to program them or integrate them in the rocket, and that is valuable, and we still do it. But through developing these units ourselves, we're also gaining this huge insight into how to build such a system, how to develop, what kind of problems you can encounter. There's lots and lots of lessons that can be learned from really finely controlling the manufacturing and development process. So I'd say that is something that is, pretty unique about our association, about AGH Space Systems in particular, and something that we take great pride in.
Yeah, and I think that it really came to notice on different occasions. For example, on competitions when the judges asked us whether we bought some parts or whether we make it ourselves. They were really surprised to know that, for example, our members sewn the parachutes themselves. They're surprised that how come we didn't buy them. So yeah, but just like Wojtek said, the mission of the organization is not only to build those projects, because it's really cool to build a rocket, but to also gain some knowledge to research and to I think provide a good entry point for the scientific part and to actually be able to find ourselves in the scientific world.
What software do you use to design the rocket?
From the basic softwares like SolidWorks to ANSYS, for example, both fluid and mechanical. To simulate the rocket during the flight, we use OpenRocket, which I think is the one of the most common softwares out there. Wojtek, maybe you want to jump in on the electronics part. I'm not quite sure what particular software you're using for the development of PCBs.
So for the development of PCBs, we use Eagle mostly. We also have some students working in Altium. Then we use JetBrains products like Sea Lion for software development. They offer great integrations with the STM32 microcontrollers, so that is the primary reason why we use them. And well, what else? I think these are the primary ones that we use. Of course, the whole STM32 suite. So we use STM32 Cube MX for generating, the drivers and the abstraction layers for our units. So yeah, that's pretty much the technology stack of the electronics team. And also to add something on the topic of developing our own software. We do have desktop apps such as our ground station software and our data visualization software, which is used for both for interfacing, the ground station and basically interfacing people with the rocket subsystems. And so that is the ground station app. And then the data visualization software aids in the analysis of data that is the result of our tests and our flights. In the propulsion development process, we're obviously using NASA CEA in the initial calculations, but one of our members, for example, created an app that allows us to actually simulate the behavior of a hybrid rocket, a hybrid engine, and to estimate the performance and to create some kind of a baseline from which we can iterate later. I think there's also something to say about prototyping. So yeah, we definitely use 3D print. This is mainly utilized by, of course, the payload section quite extensively, but also the mechanics section. This is very valuable for when you want to make sure that your design is correct before you send it for full-on production, like we did with many components, as far as I know. Of course, there is also electronic prototyping, for which we use, generic prototype boards and off-the-shelf embedded units such as STM32 Nucleos, which is basically like a supercharged Arduino.
Prototyping and testing thing, especially about the recent payload, as it had to contain water, so it had to be perfectly hermetic, and it took a lot of iterations to achieve that. Really often a lot easier to see the flaws of the design and what's going to go wrong with the design when you actually see it in person. So yeah, for example, CATS software really helps, but still seeing it with your own eyes and being able to take a look how it would fit in the overall rocket makes the debugging the ideas, I think, a lot easier. It's better to see that there's something wrong in the development process and not when you're on the launch pad. So, yeah. Yeah, the earlier you detect the problem, the less effort it takes to fix it.
Do you use a commercial engine, or do you plan to produce your engine?
Most of the rockets we've produced use if not all of them, I think maybe one rocket in the past used a commercial engine, but the majority of them use our own engines. We develop them in-house, I'd say. Most of them are hybrids. We're working on one liquid engine. As for the oxidizer, we stick with nitrous oxide. It's relatively easy to handle. It's relatively safe. Not that expensive. A lot less problematic than for example, liquid oxygen. You don't have to do with cryo and all of the stuff. I think it gives decent performance for the effort that you have to put in to actually handle it and develop. It's a little bit problematic because of the two-phase flow. That's kind of tricky, but yeah, there are some ways, and a lot of practical development, I would say, is really crucial to actually test those ideas and to actually see whether you were wrong or whether the calculations were correct.
I'd say that this oxidizer is not that expensive unless you try to buy it in Portugal during EuRoC, because I know that last year it costed like 10 times more than in Poland. So it was kind of a big surprise for us, and we didn't expect to pay so much for it. But it is what it is.
What electronic sensors do you use?
We use several different sources of avionic data. So we're using accelerometers, gyros. We also have pressure sensors in the combustion chamber, as well as the pressure vessel, for monitoring both how much fuel we've got and also how the engine is behaving. This data is taking into consideration both during testing and during flight. And also, last but definitely not least, we have barometric pressure sensors, which are actually a particularly reliable source of altitude data. Also, to touch on the topic of custom printed circuit boards, as I said, we always try to control our manufacturing process to the fullest. So we do develop our own PCBs, our own electronic units, and these are mostly STM boards. But recently we've also been looking into Nordic Semiconductor NRF boards for short-range wireless communication. So we might be also trying to experiment with that in the future. But for now, it's definitely STM focused. The whole system is based on STM boards, and they're actually one of our sponsors. So we're very thankful for their support, because their products are simply awesome and we love working with them. So we are very grateful for that sponsorship deal for sure.
Yeah, and about cameras, maybe Basia, you could say something about cameras in our payload, because I think it's super interesting.
Cameras are used to monitor the living organisms inside of payload. I don't know the specific model that is used, but they are managed by Raspberry Pi boards. So it's not quite a complicated system, but apart from that, we also have our payload PCB board that is designed by our electronics team members.
How do you transfer data from the rocket to a ground station?
The primary medium of communication is actually via LoRa, and we use the 30 centimeter, so 868 megahertz band for that. This communication is based on our proprietary protocol that we developed in collaboration with the members of the software team. So basically, our rocket subsystems communicate with each other via a CAN bus, and one of the systems called Chapla has a radio interface with LoRa, which relays all the communication, or all the communication relevant to the ground station, and it relays that information via radio. And then there is another LoRa unit that is plugged into our laptop, which is running the ground station app, which communicates with the rocket module, and of course presents all the data in the ground station app. So this is how we basically handle telemetry or our primary telemetry, and also how we control our rockets systems during launch. So that means, operating during launch, and of course also during engine testing. So this involves, controlling all the fueling mechanisms, the valves, of which there are quite a few, monitoring pressures, monitoring altitude, all that sort of stuff. Additionally to that, we also have an APRS system in the 70 centimeter band, which is actually mandated by Spaceport, if I remember correctly, but EuRoC probably as well. I think they actually share these rules, that you need to have an APRS system. And this is basically for, to be able to receive standardized packets, not proprietary protocols, but just standard APRS packets. And this is mainly for the competition marshals to be able to track the altitude and the position of the rocket themselves. And I mean, we also use that system. It is mandated by the rules, but it's not only for the marshals. We also take advantage of that as a redundant system that indeed often proves very, very useful during recovery.
How do you make your launch rail?
So the launch rail is, I think, a pretty basic system that's made out of the aluminum extrusions. We can basically put as much of those sections together as we want. We separate them, I think, to 1.5 meters sections. It's kind of modular. It's kind of difficult to actually transport it on board of a plane, so we weren't able to actually take it with us to the United States. but for the launches that happen in Poland, for example, during the experimental rocket launches in Drawsko, it's actually quite, I think, useful. that's the way to call it, and especially that we're launching hybrids. The velocity of rail is slightly lower than the solids for the solids, so the longer rail is quite necessary for us.
For ground support, we have, of course, the fueling system, which comprises of pneumatic or pneumatically controlled valves, which are used for fueling the rocket at a safe distance. Because, of course, once you're dealing with pressurized vessels, you have to take safety precautions. So we also always do that remotely, and it's also mandated by the Spaceport and EuRoC rules. So this is one essential part of our ground support equipment. And we also do have an on-rail battery charging system. This is something that is not mandatory, but once during a competition, there was a situation, it was before I was in the organization. When we went to Spaceport, there was once a scenario where we were held up during launch operations, where our rocket was already armed and fueled and on the launch rail, but we couldn't launch for different reasons. And so we had to just kind of sit there and wait while the battery was slowly but surely running out. And once we finally were cleared to go, or rather before we were actually cleared to launch, unfortunately the batteries died on us, and this was a very big problem. So ever since then, we've taken great care to safeguard our operations and to safeguard our power source. So we have redundant batteries on board, we have redundant power systems, and of course we have the on-rail battery charging system. So like triple or quadruple redundancy, just to make sure that never happens again. That is a big concern for us, for sure.
What recovery system do you use?
So as far as the mechanical part of the recovery system is concerned, we're using dual event recovery system with a drogue chute and the main ring cell parachute. We have a black powder separation system. Pretty simple, pretty, I think, dependable system. Yeah, it's relatively easy. It hasn't failed us in the past. So
we actually have a topology which consists of two systems, and one is commercial off the shelf. So we use an Easy Mini, which you might have heard of, which basically you just you program it through an app on your laptop or on your desktop, and you then wire it up and it's ready to go. And we use also a separate battery for that, just to make sure that it's as independent of the whole system as possible. It has its separate arming system. It's got its separate black powder charges. So it's one system. And then for redundancy, and then we also have our own system, which is developed by us. And so this one is, I'd say, quite special, because our own developed system actually comprises of 3 different electronic units, which is optimal for redundancy and is kind of, like the state-of-the-art solution for aerospace applications. And how we solve this is we actually have a voting system between the 3 units. And whenever some decision is made by 2 of the 3 units, then this is the decision that we go with. And this is great both for isolating mistakes or errors made by one of the units, as well as safeguarding operation whenever one of the 3 units fails. So it's a system architecture that we are quite proud of, and we still work on perfecting it. The way it works is one of the systems has the black powder charges connected to it, and it is the judge of the operations. And the other 2 systems have also their own measurement systems, or measurement units, and they make their own decisions and then communicate via the CAN bus with the judge to communicate their measurements, and then the judge decides which measurement it will ultimately go with. So yeah, that's something that is a quite interesting consideration. And as I mentioned previously, we use accelerometers and barometers or barometric pressure sensors mostly for our measurements, but this whole problem of algorithmic data fusion and analysis and filtration is something that we're constantly developing. You might have heard of Kalman filters, which is also something that we constantly work on developing and refining. So yeah, there is a lot of interesting things going on there.
What is your payload?
Generally, we always use our launches to do some kind of cool science experiments. Launching a double mass is just a waste of space in the rocket, if you ask me. And there's always someone in the team who has some idea what to put there, even if it's not purely scientific. Lately, our experiments are focusing on the future settlements on other planets. They're mostly biological, but also, of course, require some interdisciplinarity. They need to be equipped with sensors, electronic sensors, and also require some mechanical complexity, as I've mentioned earlier. Right before I joined the team, we had a really cool experiment with bees to check their condition after the rocket flies. As pollinators, they could be quite useful while settling on Mars. Our current project includes Neocoridina davidi shrimps. They could be used in aquaponics food production systems as nitrogen producers. The aim of the project is to develop a safe way of transporting the shrimps in a rocket. And for that purpose, we sedate them with anesthetics. It should alleviate the stress during the flight and increase their chances of survival. I also think I mentioned that before, but for the future project, we want to broaden the scope of the project and make a payload in which we can place any insect or small animal to check their performance during the flight. Our payloads are in CubeSat form. Last one was for you. They're not deployable. We recover the payloads along with the rocket. They have, of course, their internal power source independent from the rocket, so they don't rely on any specific rocket. And it is also a requirement for example, Spaceport America Cup. And at the same time, we are also developing experiments for the stratospheric balloons. Lately, we've been focusing on evaluating space radiation effects on different human cells and also developing the equipment needed for that, so the electronics, mechanicals. And this project is still open, but also here we have a lot of new ideas that we want to test after that.
Yeah, we also have some side scientific projects that are not related to CubeSats or stratospheric balloons. Recently, we have done research on social robotics. So we were researching how the level of trust is towards our space rover is forming among members of the team of Space Rover. And we presented this on Robo Philosophy conference. As I said, we are also starting a research on the influence of isolation and lack of sunlight on the parameters of sleep. And in a short time, we will also start some research in space geology. So there's a lot of scientific projects going on. And I think it's also because this is one of our mission, not only to construct a rocket and go with it to the competition, but to contribute somehow to the development of space industry and all related areas, and to popularize knowledge about it, and to show that Poland can also take part in this industry and that we have a lot to offer.
Yeah, and actually, when it comes to scientific research, we also do some material science. We actually recently did a series of experiments on composite materials for the airframe and fins, and performed simulations and mechanical tests on them, and also presented the results during ESA conference last May.
Do you have any big announcements or dreams?
Well, I think we already mentioned our biggest dreams for this year. So it is to work on our rocket with the liquid fuel, because it is actually a project that was started, I'm not sure, but I think about 4 years ago. and for some time we didn't have funds and time to work on this project, and we've decided to move to hybrid rockets. But now we're coming back, so we hope that we'll manage to develop this rocket and go to next Spaceport America Cup next June. And we also hope to go with all our papers to IASciTech conference in January, because we are still waiting for results of our grant application to the Ministry of Education. So fingers crossed that we'll get the funding and we'll be able to go there.
What are your personal plans for the future?
I am not entirely sure what my plans for the future are. I'd say I am currently working on what's right ahead of me, and that is to develop as an engineer and get to know as many fields of the industry as possible. This might be aerospace, but I am always open to new possibilities. And also, I'd say through how interdisciplinary our association is, of course, our project is aerospace related, but you can take these skills and apply them to so many more areas of engineering, and not only engineering, that it's I'd say it's sometimes hard to decide which side of things you like most. So I'm still always learning, always experiencing new things, also trying out new technologies, and looking for my niche in this world, really.
What are your favorite space movies?
Okay, I guess it can be a hard question. Maybe I'll just start as an icebreaker. I'm not really a fan of space movies, as I always have this problem that they try to pretend to be scientific, but usually it's just nonsense. So that's really a problem for me. But I am kind of fan of some science fiction books. And there is this Polish writer, Lem, that created really a lot of science fiction books, and they are great. And there is also another Polish writer that is not as well known, and his name is Zajdel, and he also created a lot of great books on space-related topics.
Yeah, as for the movies, if I may, I think my favorite one is The October Sky, because I'm not sure if you guys heard of it, but it's based on the true story, so they say, and it really shows that really one simple event might spark an idea and actually push us towards some goals and some dreams that we want to achieve. And it is really possible to actually do a lot more than we're hoping for, and that we're actually that people are telling us that we are able.
Well, I don't actually have much to add, because I also wanted to mention October Sky. It's a very relatable story. And as Nina said, I also enjoy Lem books. I might also add one book that have been also adapted into a movie, The Martian. Personally, I enjoyed the book a lot more, but I guess I could also recommend the movie.
If I may ask, do you perhaps have any recommendations on what space-related movies we could watch? Because I'm actually definitely looking for recommendations.
Yes, I liked October Sky. The Martian is also good. I didn't really know what others I could recommend. But October Sky is nice.
Definitely will put that on my watching list, as well as The Martian. Actually, I haven't watched either of them, so I might get around to it whenever I find the time. Also, I'm astounded that nobody mentions Star Wars. I mean, it's pretty obvious, isn't
I think everyone were a bit ashamed, like, okay, is this really something that you should mention when you're like doing something on space industry? But if you're talking about like something so abstract, yes, Star Wars obviously is great. And Dune, this is also kind of space movie. Maybe not so much, but a bit.
Do you have any questions for me?
Okay, I have actually one question, because I was curious, because you asked us about our plans for the future, and I was wondering, well, because you started so early, you could say, your career in space industry, what are your big plans for the future? Like not for the next year, but I don't know, in 10 years or something.
For the next 10 years, I probably will do university and also high school and probably complete middle school. I think and I'm also making a team in the closest university to me. I should expand that. And I think it would be nice to develop like a liquid fueled rocket engine made out of cardboard, so I can have the first cardboard made liquid fueled rocket engine.
Okay, so we keep fingers crossed, and we hope you'll do the same for us in our liquid rocket.
Our teams may very well compete one day.
It will be in a long time, probably.
Well, probably we won't be on our team anymore, but I think this is not the last that you will hear of AGH Space Systems. So
hope so.
Wait, will you go to EuRoC next year?
Well, we'll see, because that depends on the funding that we get from the university and from the Ministry of Education, because it's hard to finance both Spaceport America Cup and EuRoC, because they are quite close one to each other. But maybe, I think we don't know yet. We'll have to decide somewhere around maybe January this year.
Because my team are thinking that maybe next year we'll go to EuRoC, but I don't think we'll make it next year.
Okay, whenever you go, if it's next year or in 2 years' time, you can always contact us. We have the same mail, so even if we won't be in our team, someone will receive the mail, and hopefully he or she will write you back quicker than I did, which I'm sorry for. But it's really, we have a crazy time around our competitions, and it's really hard to get time to get a proper sleep, so it's also hard to reply for all the mails. And thank you for the interview. It was a very interesting experience, and I think this is the first chance that we had to give such an extensive interview and to tell so much about our activities.
And thank you for being here.
Thank you very much.
Thank you for having us.
Thanks.
Have a good day.
Thank
or
you.
night.
Yeah,
Very nice meeting you. So yeah, take care.